Hey everybody, Dave here. Today I'm going to be doing some more C# practice. Last time we did largest series product, which involved math operations and integral numbers. This time I'm going to be working on an exercise called Pascal's Triangle. And just to mention, this is in exercism.org, and if you haven't used it, you should because it's amazing. So I'm going to go into Pascal's Triangle. It says in progress because I clicked into this a little bit earlier and I thought through it some. So I have a little bit of an idea where I'm going with this, but I definitely do not know how to do this. The instructions say, compute Pascal's triangle up to a given number of rows. In Pascal's triangle, each number is computed by adding the numbers to the right and left of the current position in the previous row. So what that looks like is that if you start with a 1, then you will end up on the second row with 1, 1, and then 1, 2, 1. And the reason for that is that, for example, take this 2, you go up to the previous row, to the left, grab this number, go to the right, grab this number, add them together, and that equals 2. So for example, the 6 is because of 3 plus 3 equals 6. And you can continue that infinitely to make as big of a triangle as you need to. When I go into the editor, the first thing, this is what I saw that made me realize this is going to be harder than I thought it might be, because actually solving this problem doesn't sound particularly difficult for me. And I can conceive of how to do it because it's just a matter of referencing previous rows, doing a little bit of math. It's not that hard. But I look at this method that it's started off for me. It says a calculate method. The input is just an integer of rows, and that makes sense, right? It's just telling me how many rows the triangle should have. But the return type is IEnumerable of type IEnumerable of type integer. Now, the reason they're doing this, I assume, is that what they're going for is like, this is the overall IEnumerable, which will contain rows. And then inside of that row will contain multiple sort of columns or positions for inside of like the array. And each of them will be of type integer. So now if I go over to the test cases, I can show you what that looks like. So as an example, their input might be this calculate, and then they give an input of 3. And then the return that it's expecting is an array or some type of IEnumerable that has a row that has 1 in it, a row that has 1 in it, and whatever else. What I'm unsure about, because I've done this before where your return type is IEnumerable and you're supposed to do like a lazy return, and I need to figure out how that works when the type is IEnumerable of type integer. Because what I'm thinking is that we need to have some kind of loops in here and it will return. I was originally thinking, I'll return the entire row. And then because it's marked IEnumerable, the method will just handle that, right? Whoever calls it can return all of the rows or just one at a time in a for each loop. But since this nested type or whatever is also IEnumerable, I'm thinking that what I'm supposed to do is return a type of integer only. Okay, so here's the thing. You're going to hear me say some very incorrect information at various points in this video. And I want to point out that the specific wrong thing is that I kept thinking IEnumerable means lazy return. And that is not the case. They often go together. You often will do a lazy return so that people can retrieve just specific rows at a time, or they can choose to pull back an entire list. But throughout this entire video, I didn't realize that until nearly the end. So every time I talk about IEnumerable meaning a lazy return, just know that I was wrong there, and those two are just separate things that often go together. What I like to do, and maybe other people do this too, I don't know, I find I have a hard time thinking through this if I treat it like IEnumerable is supposed to work with a yield, like lazy return or whatever. I am going to create a list initially, and I'll probably have to refactor this and to remove it because I don't really need it to work like this. Not sure. We'll have to see. I think I want a list of integer, and what I'm doing is mimicking this up here. So we'll call this list equals new list of type integer. And we'll pretend again that I'm going to return the list at the end, but I'm not actually going to do this. This will look different. I know at some point I'm going to need to add items to the list. So let's call this something like num, because I'll need to add numbers to it. I'll create a variable called num. We'll just set it to 0 for now. Okay, so the first thing now that I think about it is every single time we will always be adding just one number to the first row no matter what. And that's if we reach the first row. So let's do a little validation actually. We can go if rows is less than 1, then throw new argument exception. Okay, let's redo this a little bit. This is going to be list of type integer. So we'll call this like parent list. And then I need just a list of type integer, row, new list of type integer. And I want to add just a single number to it. So I'll just do row.add1. And this is our first row. And then we could start looping every time after that. We'll just loop up to a certain number of rows. So let's do a for loop, see how that looks. For int I equals 0, I less than rows, I plus plus. I think we actually want I to be 1 because we've already added a row to start with because we'll always have at least the one row. And if rows is, let's say, equal to 1, then I less than rows means that this will not be true the first time, and so it won't run this at all. So we should be fine there. So let's say if there were 2 rows, it would run this one time, and what we want to do is add another row to it that contains a 1 and a 1, and we need to calculate that though. Inside of this, I think we want to go for each int j in row, and this will be actually need to point to the previous row probably, but we'll figure that out. Start with like int first result equals 0 plus j. We want int last result equals j plus 0. Maybe I should have done row.add, and then I should have gone parent list.add row. And so now this first row is actually in the parent list that will get returned at the end. And then we start looping over rows 2 through whatever, which is technically, index 1 through whatever. Do I reuse this row though? I think maybe I will overwrite it. So row equals new list int like this. So I'll just reuse the same variable. I will loop over something like the previous row or whatever, and then I will do row.add. That's actually that row.add is going to be inside the for each. I want parent list.add row. And so that way upon each new row, I'll add it to the overall list. I actually don't need any of this stuff down here. For each int j in row, and what we're referring to is the previous row because we've overwritten this. So we need to change this to reference the previous row. So maybe what I could have is like one list to track the previous row, and another list to track the current row. Previous row, current row. This one will be previous row, and then the current row doesn't actually need to be defined at this level. I think it can be at this level. And then I'll add to the parent list, we'll take current row like that. Inside of here, we'll end up adding like current row dot add first result and current row dot add last result. Let's see what other things we've got wrong. I know that row dot add is incorrect now, so I guess this is going to be like previous row. Oh, I see. That's why I needed to define it up there. Yeah, we'll do this. Current row equals new list int. Whoops. Int. We're not defining this, but we are sort of overwriting it. And when I add to this list, we want to go current row dot add 1, and this is what handles our first row. Then when we add that to the parent list, we want to go current row. And then I think what we want to do is set previous row equal to current row. Now the question is, do we copy the list? I think we do copy. Let me look that up real quick. So I tried to Google this a little bit, and there are ways to copy lists. It's a little confusing. I'm not even really sure what the benefit would be. So in this case, what I want to do is just, I think what I'm doing when I go previous row equals current row, the object or the list that's underneath this, it just gets sort of referenced to from this variable. And then when we get down here, oh, the previous row needs to be done down here as well. So for each of the rows, parent list.add current row, and then we set the previous row to whatever the current row is. When we come up here, we'll end up clearing that out. I guess I could just do it up here. Let's do that. See if this will work. So then I can take it out of here. So whenever we go into here, it'll set previous row equals current row. We'll be basically reusing the variable of current row to point to a totally new list. And so we're creating a new list every single time. But I mean, I guess it depends on how big the triangle is to whether or not that's super inefficient. But I don't know if copying the list would even make much of a difference there. So I think it's fine. Maybe it's actually better that I don't copy. It's probably better that I just use the original object and just point a different variable to it. I didn't really think about that. Okay, so before I keep going, let me just make sure my code looks good here. So I don't think this is beneficial. I'm going to just set it like that. The first and last will always be 1. So I don't actually need to even do any math here. Am I crazy about that? Because it's going to be 0 and 1 goes to 1. 0 and 1 goes to 1. 0 and 1 goes to 1. I didn't realize that until just now. So I can actually just add to the current row a 1 here. Then I can add a 1 to the end of it. And then in the middle is where I'm going to do a little bit of math potentially. So actually this goes outside, I think. Yeah. And then inside this looping, if previous row dot count equal to 1, then we break. And that should break out of the for each loop, go to here. So if it's the first row, it'll do this, break out, go to this. If it's like, let's say it's the third row, and it will be building the third row. We go 1 here, then we do this 1 here, and this for each is supposed to handle creating this 2. When it loops over these items, it actually needs to, I think maybe we need a for loop here. For int j equals 0, j less than previous row dot count j plus plus. We'll need to do this. Although I think I may be able to handle that here somehow. Let's get rid of our for each. And my thought is that you have to add each number to the next number. So like 1 plus 1 would be 2. There are 2 items in this. I think this might need to be previous row count minus 1. And then we'll see if we don't actually need this. Current row dot add previous row, and then we reference it the position of j plus previous row position of j plus 1. At this point, this looks correct to me if this return type were not an IEnumerable of type IEnumerable of type integer. If this was just looking for, like if this said list and list here, I think that I could just do a return on this at the end, like return whatever list we were doing, parent list, and I think that would work. But if I run it now, it will tell me that it can't convert this automatically to a type of IEnumerable. And I just want to see what the error is. I assume it's going to show me this full. What? I don't understand. It passed on everything. I don't get it. I don't understand what's happening. No! Ah! The only reason it failed anything at all is just that this check might not need to throw an argument exception. It should instead return, I think, an empty list, whatever, something. So I'm just going to take this and we're just going to instantiate it or whatever the word is there. Initialize, instantiate is probably both of them. We're just going to return parent list, and it will just be empty. You know, some people might be okay with getting the right answer and not understanding why, but I am not one of those people. This is going to frustrate me. I don't need this thing because I was right about the logic. When I've done IEnumerable before, oh, why did this work? Oh, what? Wait. This just says IEnumerable. Oh my goodness. Oh, I'm dumb. Okay. I see what's going on. What I was getting this confused with before is when there have been times where the return type was IEnumerable, and I thought IEnumerable return type always meant that you do a yield return. And now that I think about it, I suppose that doesn't necessarily mean that. It seems like a good idea. You don't have to do that to satisfy the exercise. That also explains why when I did this before, the instructions before actually said that it would test to make sure that I did the yield return. And only one of the test cases checked that, which meant that it didn't actually require it on all of them. And in this case, it didn't say anything about it. So there was no requirement to do that whatsoever. So my thought here about how this would have worked was exactly correct. And I guess I've arrived. I can go be a C# developer. If you need a new C# developer, please let me know, because clearly I have displayed in these recent videos that I'm just the best C# developer and I never get anything wrong. Even when I think I'm going to be wrong, it turns out I'm just right all the time. Please don't go fact check that. Thanks so much for joining me. I guess we should click submit. Let me click submit to see what it just says enumerables. There was no requirement for anything dealing with the yield return, lazy execution, whatever. All right, well, that was Pascal's Triangle. We all did great today. Thanks so much for joining me, and I'll see you in the next video.